All right, good morning. So let's discuss a small component of Kirchhoff's voltage law and Kirchhoff's current law. Okay, so some of the numericals you get are on KCL and KVL. Okay, so let's pick up something which is very simple and very basic. Okay, so let's see you have a single loop situation. Generally, KCL and KVL is only to be used when you have multi-loop, multi-EMF system. Let me just show you something, small components. So you have this circuit and you have these multiple batteries which are available to you, and this is the situation. So this current is known to you. For example, the current here is some value which is 2 amperes, and it enters this place and leaves here. You have a current of 1 ampere here. You apply Kirchhoff's current law here, you will have 1 ampere here also. And what is known to you is that these resistance, some values there, X, Y, Z, and maybe, U. So you have 4 resistors, and there are 2 batteries, maybe 5 volts and 10 volts. The focus of this approach is to find what is the potential difference between point A and point B. If you have to find the potential difference between point A and B, there are multiple ways you can do. The first is you decide any path you will take to reach from point A to B. So I have selected this path, for VAB. Okay, this is one. Now, if you write the expression for VAB, you would realize that I have taken the direction upwards. So the direction I have assumed is upward, and the current is also upward. So the potential drop is -2 multiplied by Y. And if you go on this side, it will be -2 into X. And once you reach this place, you are having minus U into A, okay, where U is in ohms. So you can find the potential difference between VAB, which is the point, A and B, with this method. Some people, some students would like to not adhere to this, but they may like to go through another path which looks like this, okay? And they may like to apply the same strategy, but they follow an alternate path. So this is the alternate path which is shown in, okay? So this is the alternate path. If you apply the Kirchhoff's, or, the concept of potential difference between 2 points, and calculate VAB, you can also do that. So you can see there is a drop in potential in the second path, across the battery. So you will write it as -5. And once you move in this direction, you can see the current here is 1 ampere, which is given to you. And the direction of motion is this. And therefore, this will be treated as a gain. And you can write this as 2 into 1. And as you move upwards, again, positive to negative is a loss. So this becomes -10. So you can see this, the strategy of applying VAB, either you go from this direction or you go from this direction, okay? It doesn't matter. The VAB in both the situations will be identical. And another student comes and says, I would like to use this path to calculate the potential difference. If you use the third path, which is shown in green, you would still get the same answer for potential difference. So you can see you can calculate the potential difference between 2 points by having multiple paths. The potential difference never changes. And if you find 3 equations and you solve them, you can actually find the values of resistances given in the question, because the current is known. I hope this helps you. So once you're done with your Kirchhoff's voltage law and Kirchhoff's current law, The last step probably will be to find the potential difference across 2 points. So do not worry whether you're following the path number 1 or the path number 2, or you're following a path which is path number 3. It doesn't matter which path you take. The potential difference between A and B, irrespective, remains the same. Thank you very much.